So, ladies and gentlemen, please be seated. Our first scientific session will be moderated by Professor Herto Dwi Arisyadi. After finishing his doctoral degree from Hokkaido University, he teaches at the Faculty of Civil and Environmental Engineering ITB. Now he serves as the Director of Facilities and Infrastructure ITB. Without further ado, please welcome Dr. Arisyadi.
Okay, the Honorable Wiki Sensei, Yusuka Sensei, Komori Sensei, Takashi Sensei, Kamitaka Sensei, and other guests from the Tohoku University, and also the professor and also the faculty members of ITB also join us today, and students, distinguished guests, ladies and gentlemen, good morning, Ohayou Gozaimasu, Assalamualaikum warahmatullahi wabarakatuh. So from now on, we will have a scientific session as mentioned by the Master of Ceremony, and then we will divide into two sessions before break, lunch break, and after lunch break. And then before lunch break, we will have four presenters from both from Tohoku University and also from ITB. And then in these first sessions, we divide into two parts because every two speakers will be followed by one question and answer session, and then we will move to the second part, and again we will have two presenters and followed by question and answer sessions. And during this session we will have two speakers from ITB and also two speakers from the university. And then in this part, in the first part, I will invite first is Professor Daisuke Komori. So Daisuke Komori is the specially appointed professor from Tohoku University, and then he was graduated from the Tokyo University of Agriculture and Technology of Japan, and currently professor in charge of disaster science at the University for International Excellence, and also board members on promoting observation and monitoring of climate change impact, Ministry of Environment, countermeasure against woody debris in reservoir, and urban flooding countermeasure in light of change, Ministry of Land, Infrastructure, Transport, Tourism, and so on. So many activities he has, and so many, of course, so many publications. And then I know him during my visit 6 months in Tohoku University, and he has expertise mainly in hydrology and water management. So now he will have presentation entitled "The Hydrology and Integrated Research on Disaster Risk Reduction." So, Komori Sensei, please, and then you will have 20 minutes for the presentation. Thank you so much.
Thank you. So, selamat pagi. So, my name is Daisuke Komori, the professor in Tohoku University. Thank you very much for the kind introduction. And so, I'm very glad to have the opportunity to talk here, especially so the excellent day, also the bridging ceremony, also the double degree program between ITB and so Tohoku University. Then I have so the now the facility belong to the Green Goal Initiative, Green School of Environment Studies, International Research Institute of Disaster Science, Tohoku University. So firstly, the Vice President of the week Sensei explained. So we are glad to the awarded to the one university in Japan, so the International Research Excellent University. Then I am the principal, the investigator, PI of so the one of the core projects in this project, the disaster science. Therefore, now I need to work in not only to the grad school environment study. Of course, big contribution. Big contribution to environment studies, but also the contributing with the Green Goal Initiative and also the disaster science centers. Then today I'm here to the talking also the what my research and so the my team, also our team in the graduate school of environment studies in the regarding also the hydrology and the integrated research on the risk reduction. And also the personally, so Hero Sensei, big congratulations. So firstly, we talked the double degree program between the environment study and the ITB 2017 and 2016 when you're visiting a sabbatical stay, in the Tohoku University. But finally, you not only, of course, I know that many contribution to the your idea is finally success to the leading so these programs, but I'm very happy now here so our first talking so finally is the bridging the good so the collaboration between the two universities. Okay, so let me briefly introduce. Do you know hydrology? I think the who's studying the civil engineer, maybe you know the hydrology, but I think here is the collaboration, not only the civil engineer and the environment study, also the engineering and also the graduate school environment and engineering. So anyway, hydrology, sorry. Not working. Okay. Okay. Hydrology is a field which covers the entire history of the cycle of the waters. Okay, there is the rainfall. After rainfall, the rainfall is distributed to the one of the rainfall is evaporation or transpiration from trees. Some of the water is infiltrated to the soils. The remain is the flow on the surface as rivers or lakes. Okay, the rainfall is the three pattern into the soils on the surface or the atmosphere. Then atmospheric water is again to fall down as a rain. Therefore, water is circulated. This is the hydrology. Then human beings, which the water we use, surface waters, groundwater, because the water is very simple two principles. One is the gravity. Water never flow from the low to high, just high to low. The another, heat energies. Energy is making vaporizations from water liquid to the atmospheres. Therefore, which water is useful for human beings? River and underground water is main water resources for human life. Therefore, as I told, the water cycle itself is naturally cycled from the rainfall, infiltration, river, and evaporation. But human activity, we large in taking the water from the water resources, river, and underground. Therefore, our activity is strongly impacted on the natural water cycle. Therefore, our field, we need to understand not only the natural cycle of the water cycle, but also how interacted with the human activity with the natural cycle. Otherwise, we cannot understand how water cycle change. If water cycle change, as I told you, river water may be decreased or groundwater may be decreased. That is causing the strong impact of water resources. Well, if recently changing climate, increasing rainfall intensity, that causing heavy rainfall, causing the flood. Or to understanding the water cycle is very important, especially how impacted human activity in the water cycle. Then, water cycle is, as I told you, one of the fundamental systems within the climatic systems. Okay. Anyway, water, there is a water. No water, there is a dry. If Earth is a dry ball, of course, no lives, it survives. There is a water, therefore we can survive. Okay, so it's circulated for better or for worse. Then all living things, including humans, interacted with the water cycle. Therefore, we cannot ignore us. Water is the fundamental cycle system in the climatic systems. Then two basic characteristics is very important. If we can fairly get into the water in the Indonesia, Japan, any area, we don't need to consider so difficulty. We just consider together, no locality. We can design the good facility for the water resources management, dam reservoir, or groundwater. But what is the issue? Rainfall is different. So the Indonesia locating in the equator, one of the heavy rainfall countries, abundant rainfall countries in the world, Japan as well. But on the other hand, the European countries just 500 millimeters per year. That is a very small rainfall areas. Therefore, rainfall distributed quite different in the locations. Therefore, we need to consider that's uneven distributions on the in-time and space. Then, as I told, it changed by the human activities. Then, how affecting the human activity on the water cycle? So, rapid population growth and expanding the human activities. These two is the main cause to impact it to the human changing the water cycles. Then, population increase. So we need food. We need we using car. We need the energy consumption large by the human increased population. For food, we need more further agriculture yield. We need more water for irrigation for agriculture yields. Therefore, population increase directly working for the water cycle change. Vice versa, also the expanding the human areas. So if the population is limited, we can choose low risk area, low hazard area. But expanding population, expanding areas, we need to sort of giving so residential area for more high risk area, high hazard area. If who living sort of high hazard area, high risk area, so government needs to consider more investments for the facility for flood control. Or if there is nothing the money investments, so the poor community, because that area is low prices, so they living so the they choosing some more cheaper area rather than so the residential area. As a case, so poor community facing so the negative spiral of so the damage and so the damage and so the education system. So we need to anyway. So the back to my topic. So rapid population growth, so the expanding human activity strongly impacts the water cycle. Then especially so that is making also the poor and so rich communities differences. We need to consider about that. Then water issues is very simple. Okay. Maybe this is just the main message from me here. That's very simple. Just too little water or too much water. That's only two issues. Okay. So too little water issues is so the imbalance water supply and demand, even drought. Okay. Then water pollution and ecosystem degradation. Also, this is the too little water issues. Do you understand? Because so anyway, human activities, we don't making the perfect world, perfect source facilities. Anyway, there is the advantage, disadvantage. So even though so we have sort of any industrial estate or industrial work, also the agricultural work, maybe we will reach releasing so some of the, for example, the fertilizers or something chemicals or the toxic some things into the rivers, into the groundwaters. But if there is a large amount of the water, even though you drop in 1 drop of the toxics, the concentration very low. But if there is a small cup of the water, if you drop in 1 drop of the toxic, that is the high concentration might be kill your life. Okay. Therefore, of course, if we perfectly decreasing the toxics releasing from the human activity, perfect. But unfortunately, this is very difficult. But if we can have there is a big capacity of the waters, even though some toxic, some concentration is developed in the waters, this is a low concentration. That is a safe life for the human beings so the lives. Therefore, this is the too little water issue. How when there is a dry years, dry season, is less water capacity, water in the rivers. If you releasing so large amount of so the fertilizer or the insect fertilizer something that is increasing so the concentration of so the nutrients. That's causing the eutrophication something. Anyway, so this is too little water issue. Too much water issue is very simple, flood. Okay, there is too much water, that is a flood. Okay, then to understanding the hydrological cycle, rainfall, the balance between so the rainfall and so the river and so the flood, so the groundwater condition, then we can discuss which is the too little or too much water issues. Then that is connected to the water supply issues or water quality issues, and also the water flood issues. Then these too much or too little water problem is connected to these 4 big issues in the world. The first, drinking water, water for life. Still in the 1/7 of the world population faces difficulty to the access to 20 liters per day of the drinking water in surrounding 1 kilometer areas, especially the African countries. So after solving these 2 issues, next water issues, water for food, agriculture production, and economy, industries. Okay, so as you know, so the still so the rapidly the population increasing in the world, worldwide, then taking the water in the agriculture sector and inter sector is around twice or 1.5 times increase the amount in the 1995 to the 2025. Okay, then when the third issue is the water issue, is water for the human and ecology. Okay, so as I told you, so that we are basically obtain the water resources from river or groundwaters because water naturally gather from the high to low. Where is the lowest area is river, and so the underground. Therefore, we prefer to using these 2 water resources. But if you use all river waters, of course there is a rivers ecosystem. No water, so all ecosystem in the aquatic ecosystem is collapsed. Therefore, we need to consider how much we can balance balance with the ecology or environment and the human activities. Then last issue is the changing climate urbanization, as I explained, causing the changing rainfall distribution, rainfall intensity in the severe flood. Serious flood and drought is occurred in the city scale. Then these water problems may bring the international conflict. Then Dr. Ismail Sergren, and he's the former vice president of the World Bank in 1995. Also, he mentioned the war in the 21st century will be the fall over the water, not oil, rather than oil. Okay. Then in the world now, so there are many now water conflict, international water conflict, especially where it's locating the international rivers. So fortunately, Indonesia and then Japan, we are just one island. Therefore, even though we have some troubles, water issues, in the upstream, downstream, but finally, central government will coordinate its discussions, and so the mutual agreement how we can utilize its the water allocation in upstream, downstreams. But in the case of the international rivers, so there are the different countries. It's very difficult to coordinate mutual agreement, especially for example, in India, it's the upstream country of the Ganges River, also the Indus rivers. The downstream countries, so the Pakistan, Bangladesh. So they are very difficult to the coordination. It's the good agreement how surely the water resources in the both rivers. Then I explained by now the climate. So there is a natural hydrological cycle between the climatic factor or geomorphic factors. Then human activity is the intervention to the natural environment, the water cycle. Therefore, hydrological feature, hydrological feature is quite different. As I told, Indonesia is the abundant rainfall area. Maybe your area, you not so much seriously worry about the water resources, or you need to concentrate on flood management, or in the case of European countries, more drought is a severe condition. They need to consider a drought rather than the flood. Therefore, we need to understand what the water issues is the main target in each country, each locations. Then we need to consider the hydrological feature in the river basin should be considered to the dynamic interaction among three factors. Then who am I? Then my research is, so I check in my publication. Now 1/3 publication in the agriculture science, then around half of the publication in the hydrology, water science. Then another 1/3 of the publication, data science and social science. Then as I told you, because to understanding, to solving the hydrological water issues, we need to understand not only physical science, but also social science understanding, and the integration is very important. Therefore, I'm very happy to have the very good balance of my publication to tackling also the water issue in the world. Then, so my agriculture methodology, so one of my research to understanding the hydrological cycle is how much evaporation from each land use, how much rainfall, how much the infiltration. This physical research observation we doing in the Thailand and so in the worldwide. And also there is my alumni in my laboratory. So we are now starting the new research, global research, global scale research to understanding the crop vulnerabilities. Especially what later I will introduce again. What are interesting because ASEAN community we're using the paddy systems, rice paddy systems. On the other hand, dry country, European countries, they using the dry cropping systems. So I want to more understand scientifically how our rain-fed, rain paddy system is the good advantage or good resilience for the changing climate. Therefore, I compared on the global scale to understand how different the behavior of the resilience of the changing climate. Okay. Then water science. I have many of the research works, but what I want to emphasize here. So flood is not only a negative. There is many discussion negative impact of the flood, but the 10,000 years ago, or too much, 2,000 years ago, okay, there is no facility. As such as flood is providing the nutrient or the surrounding agriculture area. Therefore, the people living around 1 kilometer far from the, for example, in the case of Egypt Nile River, they living where they making the relationship is 1 kilometer far from the river side. Too close to the river, flood impact large. Too far from the river, this is very difficult accepting the water resources. Therefore, from the experiment, they decided that 1 kilometer is a good distance to balancing so the positive and negative feedback. Therefore, we need to understand not only the negative impact of the flood, also the positive impact. Then I doing such a research how nutrients is distributed with flood. In this Cambodia cases, also the Indonesia, as well as in the mainly Asia countries. Then also we need discussing the climate change impact. This is the governmental project supported this our project. Then social about the social science. So as I told, we need to understand the interaction between the human activity, human behavior, resilience, and the flood or the drought impact. So we are also working such a research in the governmental scale or the local scale or global scale. Then 20 graduates. I counting how many students graduated from my laboratory. There are 12. I'm very happy. So Yoshioka-sensei explained to us, this is just engineering. There are now 28 students from Indonesia, but I already have the past in the 12 students graduated. Half of the 12 is the ITB. Then I think 1/3 was the Indonesian student from the Bravija University because I have the linkage WD program with Bravija University. Then I would like to introduce some of their research. One is Dr. Faja. Now he using not here. I'm sorry that I cannot pronounce his university name, but then he the lecturer in one of the Indonesian university. Then he preparing the 3 map future forecasting the rainfall distributions and land subsidence and land use change. Maybe most of you know, if an Indonesian student, you know, land subsidence is a very big issue now in Jakarta and in Indonesia because large intake in the groundwater is causing very high land subsidence. Therefore, we need to consider to also land subsidence effect on the flood. Then integration 3 map to the analyze the flood simulation. Then coupling with the adaptation measure. Of course, we are also counting the Garuda strategy, also making a seawall in this publication. But also not only the seawall, because seawall is not cancelled. So now you are choosing the transfer the city, Jakarta, to the another island. But anyway, so also the constant green fractures, other countermeasures. Then, but this is would like to emphasize. So blue line Tokyo. Then red line the Osaka. Land subsidence in the from the early 19th century to 2000. Okay, so Tokyo we experiences already 4.5 meter land subsidence by large taking the groundwaters, especially the before World War II, the after World War II. Anyway, the government doesn't have the power to design the facilities, especially after World War II. Everything is banned. Therefore, government have to allow to utilize this the groundwater for private sectors, also the industrial estates. Therefore, the result is that we are facing the large subsidence in this 20 or 40 years. Then how we make stop? So the finally is the government making the policy act prohibition for the groundwater taking for industry business sectors. Then after that, we successfully make stop the land subsidence. But what is the fact? Once land subsided area, not recover. Therefore, I want to give you the strong message here, Indonesian people. Indonesia is orange color. Okay. Now your country is still ongoing the land subsidence. Okay. Now recorded around 4 meter. Okay. So always maybe some of you that taking my lecture, you remember always I just especially Indonesian student encourage you make stop these conditions. So because your government, I don't know now, but at least 3 years ago, because the shallow groundwater is already empty, then your government is promoting producing deeper groundwater. But as I explained in my lecture, you must realize to the government, also the student, also researcher, to how quickly stop the large intake in the groundwater conditions in the Indonesia. Okay, So maybe time is limited. Maybe we better rapidly closing my session. But anyway, also flood is negative impact, positive impact agricultural yield. This is the work by Dr. Bempi here. So he making crop yield estimation using satellite. Frankly to say, satellite we can catch the green colors. So changing the green colors, so he detecting the yield in Solo River Basin. Then coupling to the flood simulation, then integration to understand, try to understand what the flood depth, flood velocity, flood duration is impacting the yield. Then what is a great achievement by him? So there is we know flood is anyway worse the agricultural yield, damage, but he found positive. As I told the first message, there is a flood not only negative, but positive effect. Also, he found if the water level is small, because this is providing more water resources for the edge of the agricultural area. That's providing the positive effect. That is a very great finding. There is less discussion in the world science. So therefore, that is one of the very interesting research. Then global crop vulnerabilities. So he deriving the hazard for assessment. What is important? Here, hazard and risk. Then this relationship, if hazard is strongly correlated with risk, as a case, community doesn't have any resilience. But if even the high hazard, but the damage is low, the low correlation, as a case, community have some resilience. Therefore, to understand how different correlation is between the hazard and then damage, so he analyzing the global scale, then he found. So rice is because we submerge the water, even though there is a high drought, but the rice is a high performance, high resilience for the drought. So this is the global he analysis. Then also the further analysis, how that resilience is related to the parameters. Then he doing the principal investment, principal analysis, parameter analysis. Then he found GDP or socio-economic parameter is the second important parameters to define, to increasing the resilience of the hazard. Okay. I would like to skip here, maybe no time. So, but social hydrology, but this discussion, global scale is now, even though top science, including me, so we can using the 50-kilometer resolution. 50-kilometer resolution. Imagine 50-kilometer resolution, maybe we can discuss community, too large. Therefore, my student, she just graduated my laboratory. She designed 1-kilometer resolution the yield data. Then this is world first data. Then now she prepared the drafting of the paper. Then now we using 1-kilometer resolution. 1 kilometer, maybe we can discuss more community scale, how resilience is working in the community scale with the hazard of the water resources. Therefore, now we using the 1-kilometer resolution to using a next system dynamic model to understand how human behavior interact with the drought in the flood situation. Okay. Then also I have the world first research the woody debris in the world. I firstly developed a model for the woody debris landslide. And so last 2 minutes, 1 minute, I would like to introduce another members, not only me. So now I'm talking basically water quantities research, but also hydrology. As I told, there is a too little water issue, too much water issue. The water quantity, also water quality is this 3 professor is our team in the graduate school environment studies, who are interested in the water quality, ecology, phytoremediation, or risk assessment of waterborne infection disease. Please also contact me, also the professors, also including Heruto Sensei. And also another members is the disaster risk reduction. There are also 4 professors is also taking charge of the international disaster risk reduction science in the graduate school environment studies. So I'm very happy to hear and talking with you. So the more I'm looking forward to the working with you on the ITB and also the Tohoku University collaboration. So thank you for your attention.
Thank you so much, Komori Sensei, for your very nice presentations. I think it will inviting some questions from the audience, but we will have a second speaker and then you will have sit here, please, Sensei. Okay, for the next presenter will be from Professor Edwin Cardinal. So Professor Kadena is the professor in environmental engineering department in the field of the biological process for environmental engineering. And then Professor Edwin Kadena got his PhD from on the biotechnology from the University of Wales College of Cardiff, UK. And then he was actually the director of the Partnership International Cooperation, I think about 10 years ago, and who developed also who initiated the cooperation between the Tohoku University and also ITB. And currently, he is the Dean of the Faculty of Civil and Environmental Engineering. A lot of experience, a lot of the publications also he has. And then he is actively as the chairman of some delegates in some international meeting. And also he has many crucial projects for the Ministry of the Environment and also Ministry of Public Works. And then for now on, please, he will have presentation entitled Biological Process for Remediation of Contaminated Site in Indonesia, Hazardous Waste, Contaminated Soil, and Groundwater. So time is yours, Professor Edwan, please.
Thank you very much. Thank you, Professor Herto. Very good morning to all of you, especially for our guests from Tohoku University. First, I visited Tohoku in the year of 2008, maybe at the beginning of the cooperation of ITB and Tohoku, opening the Tohoku office in my office actually. So Kimura Sensei was there for quite some time, and I was very impressed by him because he can read Arabic without haroka. So I was in Islamic, school, but I tried to learn to read Arabic without harokats. I just couldn't. But Kimura Sensei can do that, and that's because of his wife was Arabic. So Komarudin Helmi was actually my PhD student, my former PhD student, and now he is my co-worker. He also lectures in our faculty. So my topic today is biological process for remediation of contaminated sites in Indonesia, which is actually, this is a kind of research in your terminology is just like a practice-oriented research. So next slide, please. I like to show the beginning. This is the distribution of land contaminated with hazardous waste in Indonesia. I got this data from the Ministry of Environment. You can see right from the west, Sumatra Islands, Java Island, Kalimantan, Sulawesi, even up to the Papua. So many contaminated sites, and mostly in the area where the oil and gas companies, coal companies, and manufacturers industries are located in Indonesia. So the main pollutant here is petroleum carbons, also fly ash and bottom ash, heavy metals. Yeah. So this is just to show our problem in Indonesia right now. And next slide, you can see the location of the petrochemicals power plant industrial estate. Yeah, this one is in Sumatra Island, in Java Island. Next slide is in Kalimantan. You can see so many coal companies. Yeah, and that's in the eastern part of Indonesia, Sulawesi and Nusa Tenggara, and also Papua. Yeah. Okay. So next slide. So until 2020, I think Indonesian government has been managed, of course, with the funding from mostly from the company. So they managed to clean up more than 2.7 million tons of contaminated soil. So next slides. Okay, so I would like to start my work with, we normally trying to find the bacteria from the sites. We call it microbial screening and cultivation. And this is what we are doing. Next slide, please. So we took samples from common sites. These are from, I think from one of the oil company sites in Indonesia. And then we took this into the lab. Next slide. So we try to find the best bacteria by characterizing its growth and capability of growing on the medium containing oil. So next slide, please. So this is the growth characteristic, and then we prove it by by measuring the TPS that is consumed as the carbon and energy sources by bacteria. Next slide, please. So we proved by the GCMS GC profile that all the contaminant, in this case, petroleum carbon has been disappeared. Next slide. And then we try into the more bigger reactor. This is a slide, but actually we make it synthesis by adding the crude oil into water. Very high concentration of oil, and then we try different kind of concentration of microbe, and then we can see the result. Next slide. At my left hand side, the oil has been degraded quite well compared to the right hand side. You can see the oil is still black, and then after I take it as a slide, so next slide, we can see that next slide, please. The after treatments of the left hand side, but it's the oil has changed, yeah, into a physical form more or less like soil. Even the smell is no longer a smell of oil. So we try to figure out using the GC, and then next slide, we can see the disappearance of the mostly of the petroleum carbons in the slide, yeah, and then we took this community of bacteria as our, a powerful microbe as a catalyst for degradation of petroleum carbon in the sites on the field. Yeah, next slide. So this is one of the case in a small river. It was in the southern part of Sumatra. They try to change the line of the river, but in fact they cross the oil which is buried without no one knows, underneath the land. So we need to clean up this one. So this next slide. So we made the bacterial solution in the site. So we took sample from Bandung and then flew to Lampung, to Sumatra, not as southern Sumatra. Yeah, this is in Prabumuli. So that is the reactor to nurture the bacteria, and then we implemented this bacteria into the 1 kilometer long of the river bank, yeah, left and right side of the rivers, small rivers. Yeah, next slide. So this is what was the results, and actually at the back is actually the nutrient, also bulking agent. Yeah, this one is quite remote, so we cannot. We could not bring the heavy equipment, so we used the hand tractor. Next slide, like this, and all people's working, yeah. And then we pour the bacteria alongside the river. I think this one, the first case, and then the second case. This is the in situ on-site remediation. This is still going on right now. It is in the Pertamina site in Bali. There was leaking, and the tank 14, I think. Yes, tank 14 leaking, and then until now still we are working to take out all the oil underneath, because I think the oil quite tightly attached to the soil matrix, so we need to be very patient. So next slide, we can see these are the one at my very left hand side. That is the area which were underneath still a lot of oil. Yeah, we try to dig it out by injecting with the nutrient bacteria. Yeah, to reduce the oil content in the soil and also in water. We can see where the pump and treat process is still going on. Next slide. So the oily water comes out, and then we pumped out back into the upstream, and then in the upstream there is a kind of treatment plant. Next slide. So this one is treatment plant. So we take out all the oil and then injected the nutrients and nitrogen sources, phosphorus sources, and also bacteria. And then we inject it back into the formation. So it goes like pump and treat round and round. Actually, we try to wash out the total hydrocarbon from the soil. But still, until now, it's still going on. Maybe we need half years more to clean up this site. Yeah. Next slide. So these are the, we measure the short chain hydrocarbon, which is already already above the standard. The dot lines, that is the standard. While for the a longer chain of hydrocarbon, we still need to work out. This was the data until July 2024. So we have not yet data because now it's stopped by the governments, and we are now evaluating this process. Yeah, hopefully by the half semester next year will be finished. Next slide. This is another monitoring in the upstream number 2. Next slide. This was the downstream one. Yeah, still moving. Actually, this one so that the oil actually has been moved from upstream to downstream. In downstream, we need to lift up the oily waters back into the upstream, where we have the some kind of water treatment plants. Yeah, next slide. Same thing. Next slide. Okay. That is actually the explanation. Now I would like to show how we implement the bacteria that we produce. Now it is actually commercialized already. Yeah. This is when we start making bacteria product. We call it PETRA, petroleum remediating agent. So from soil sample into the lamp. So we search, try to find the best cultures. So we immobilize to make a product in the form of granules as well as in the form of plastic. And this is our second product, which is biosurfactant, coming to bacteria producing surfactant. So we said the crude biosurfactant. This one using the biosurfactant. So to clean up the rock, which is heavily contaminated by oil. So we implement the biosurfactant. For 5 minutes, 10 minutes, and then we spray it with very high pressures, and then the oil will come out from the rock, and then we place the absorbents so that the oil will not go to the water. Before we use the biosurfactant, they use the synthetic surfactant, and it didn't work quite well. So they asked us to try to implement this biosurfactant, and this is the work, and they are satisfied with this one. And this is the example of the bacteria implemented in remediating the sand in the North Java Islands. It's with soil sample taken, and then we prepare the microbiological agent in the form of both a liquid and as well as the powder. And we did it during the pandemic, so 2 year times. And this bioremediation, where the bacteria are spread, That is to prevent the rains, yes, to keep the moistures in our in the best level of moistures. These are the example, only one section. Actually, the problem was running from East Karawang to Banten, and also to hundreds, thousand islands. So quite some time, 2 years, but it's finished. So I think that is my presentation, the end presentation. So thank you very much for your kind attention.
Thank you so much for Professor Edwin Kadena for very interesting presentation. So those are our two speakers in the first phase, first step. And then, of course, as I mentioned to you, we will have question and answer sessions. I think all of the speakers has presented the material very interesting, and they might be invite us some questions. So if there are any questions, comments, please your hand. Hi, yeah, Sapi Sensei, please.
Sorry. Thank you Daisuke Sensei and Edwan Sensei for dynamic presentation. My field is actually pharmacy. My name is Sophie. But in pharmacy, we also have like the environmental pharmacy. So your presentation give insight for me. So my question first for Daisuke Sensei. You mentioned about the flood influence to the plant crop, I think. So what do you think? Is there any also influence for the flood to the because in pharmacy we have herbal drug, so that come from the plant. Is it also will influence the quality? The first one. And the second one, we know Japan beat Indonesia, right? 4-0 in World Cup football. So I saw in the television that Japanese supporter bring the trash bag to take all the garbage with them. So I would like to know what is actually the cultural education for a Japanese citizen that always concerned about cleanliness, that maybe I can share also to my student. And for Pak Edwan, for your innovation like oil eater that you mentioned, we also have problem with the drug contamination in the water, like in the sea and so on. Maybe is there any possibility that you can also develop like organic eater to neutralize the drug? Thank you.
Okay, Sensei, please.
Thank you for your question. The first question regarding the flood is not only so the negative impact, especially pharmacy, also the flood. Then, yeah, exactly true. So especially famous research or the issues in so the pharmacy in the rivers, in the French Seine River cases, because they're using many difficult to explain. But anyway, they took the pharmacies in the bodies, and then they go to the toilet, and then also from the toilet, the waste water is also discharged directly to the Seine rivers when the flood cases. There is also the sewer systems, but the sewer system without rainfall is so the directly connected to the wastewater treatment systems. Then clean, then discharge. But in the rainfall cases, maybe Jakarta, Tokyo, where is so the very long history of the urbanization, because they doesn't have so the technology to separate sewage and rain drainage systems. We using combined system for the sewage, so the rain drainage system. As a case, heavy rainfall cases, so they cannot deliver so the sewer waters, wastewater to the treatment system, directly discharge to river systems. As a case, this causing so the big damage. Especially pharmacy, unfortunately, in so the water treatment system, we using so the biology, also the chemically. But the pharmacy, the parameter is very difficult to decompose using so the biological approach or the chemical approach. There was still this big issues, how we can consider is so the solving so pharmacies discharge issues with flood. Okay, thank you for your question. Then, solid waste controlling, we remember so the Yoshioka Center, I had a so the project with the ITB, a futures project, to how we can Indonesia, the Bandung is sort of making the good waste collecting systems and so tracing systems. Then we have sort of maybe simple here 2018. At that time, what we understand, so also there the waste bank system in the Indonesia, and also the historically 90s or 80s old community have the experiences how they collecting in the garbage by themselves, how utilize the garbage in your community, in their communities. So therefore, not only Japan, also Indonesian community, also there you have sort of good experiences, also the knowledge how utilize those garbage issues. Then of course in Japan, not educated, but there is maybe government regulation or policy, also the announcement is so that maybe strongly so the working, also the increasing so the understanding so the manner. But I think this is a Yoshiko Sensei specialist about so the solid waste management. Maybe he can answer more another point of view. Okay.
Thank you.
Okay, as for the question to me, actually in the year of 1990, it was already research on how to select a microbe can grow on penicillin. Penicillin actually killed the bacteria, yeah? But, this research is actually try to find the bacteria that can grow on penicillin. With a very careful selection, actually we can do it. So by that system, actually, we in the lab are trying to find any bacteria that can degrade a specific pollutant. But if that specific pollutant together mixed with other organic compound like as impurities, yeah. So actually, if the impurities are more difficult to degrade than the main, I'm afraid the bacteria will grow first in this one, not in the to that, I think we need to use the enzyme. The enzyme is more specific. Yeah, but this today actually I have one PhD student, but still in the first year, try to find a technique to remove the paracetamol from the river, from the sea. Yes, from the rivers. So thank you very much.
Thank you so much for the Sensei and also for Edwan for the answers. Is enough?
Contoh Sensei. So for the person who asks questions, we'll get souvenir.
Yay! Okay. We want to encourage the people here to ask.
Can you please open that? Let's show people what is it. Oh, tote bag dah.
From the Graduate School of Environmental Studies. Very nice souvenir you will have.
Okay.
You will get.
Anyone wants souvenir? Please ask question.
Yeah. Sisi munggare ba? TOHOKUDAI.
We have a lot. We have a lot of merch. Boleh pakai bahasa Indonesia, boleh pakai Nihongo.
Terjemah bahasa Sunda nanti.
Nihongo dari Jawa des.
Ya, Sensei please.
Dapat dari SPS ya, oke. Dozo.
Thank you, Sensei, for a very insightful presentation. So I'm Astin from Tohoku University. So I have one question to Edwan Sensei. So it's really nice to know your presentation again. So, so my background is geology, so I'm not familiar with for this remediation. So I have small questions about the oil eater. So how dangerous is it if we are exposed to that bacteria, or do you have any specific handling procedure?
Okay. So actually, I would like to say the story why we come up with Petra. Actually, I was with two scientists from UK and Italy. Did some pilot project in Bandung station, heavily polluted by oil. Yeah. Actually, at the time, I wanted to use bacteria, but my colleague from UK ordered bacteria from US and come up with big gallons, 25 kilos. And then my colleagues from UGM, from IPB know that we are going to use that kind of bug from US, and then phoned me, Edwan, you should not use the bacteria from outside the country because ecological impact did not know. Yeah. So then I was asked to find our bacteria in our site. So start from that. So I try to obtain bacteria and then make a similar very much to the one from the US. If we found that the activity is almost the same, then we try, this can be commercialized. So that's come up with Petra. So it's an origin bacteria. So bacteria actually, this is the soil bacteria. It is not bacteria that can cause disease. So when they have already eaten all the pollutant, the glow will be much lower, and then they will back to normal. So it is not dangerous. Yeah, I accidentally eat bacteria once. Yeah, but it was accidents. So after that, actually I ate apples, 1 kilo apples at that day. Yeah, because I believe an apple a day keep the doctor away. Yeah. So I ate 1 kilo. Yeah, that's for sure. I will kick off the doctor. But I stay 1 day. Yeah, oh, it's gonna be sick or not. So, but I'm still here today.
Yeah, it's great to know that you're still survived. Okay, thank you.
Thank you.
Very interesting answer. Yeah, I think gift from ITB because Austin Sensei come from Tohoku University. Another questions maybe from students. Yeah, please. Yeah, please. Yeah, okay. Yeah, please give microphone to him.
Good afternoon, everyone. My name is Firman Josmanenggolan. I'm from magister student in nanotechnology. And to Professor Daisuke, what's your opinion about nanotechnology for hydrology? Is there any potential, and do you think it's good? And do you think is there any harm if we use nanotechnology for hydrology problems like drought or pollutants or anything? Thank you so much. Thank you for your question. So, as I told you, the human works or human activities is there are no perfect works, perfect facilities. Always there is an advantage, disadvantage. For water resources, dam reservoir is very useful for human beings. Dam reservoir. When we make a dam reservoir, we can store the waters. Then we can use the water content for annual. But this is quite change. Is so the natural water flow to downstreams. So that is big impact of the ecosystem in the downstreams. And also that we need to force is so the resident into dam reservoir to relocate. So therefore, what we need to consider advantage, disadvantage, or benefit or no benefit is so that by human activity. Therefore, also the you're talking so about the harmful or something toxic or something. Also, human activities always we releasing is so the something non-natural the component like so the he's mentioned his research is so the petrol is so the releasing something oil or something. So there are no perfect works. Therefore, we need to consider balance. Too harmful, maybe we better to change. No hydrological technology, no solar beings. They're not giving perfect answers. You need to also consider what is so the behavior is so that harmonize with so the nature, the environments, and also the technology. Does this make sense? Okay.
Okay. Is it okay? The answer? Okay, I think because of the time limitation, so thank you so much for the communication also for Serang Kadena. I think it's very big challenge for us to solve problem on environmental in case of the quality and also quantity of the water. So I think this is the end of the first part. Thank you so much again for communication also for Serang Kadena. And then we will move to the second part of these morning sessions. We will have two presenters. Okay, and then the first one will be Masanobu Kamitakahara. So, Professor Kamitakahara is the professor of the Graduate School of Environmental Studies, Tohoku University, and then he got the PhD from the Department of Material Chemistry, Graduate School of Engineering, Kyoto University, and then now he is the professor of the Graduate School of Environmental Studies, and previously he was the assistant professor in Graduate School of Material Science, Nara Institute of Science and Technology. And his subject of research is on biomaterial, especially artificial bone and also material to clean the environment and support material for bioreactors. And yeah, in terms of publication, a lot of publication he has wrote brought up to this moment, international journal and other conferences. And for today, he will have a presentation entitled The Design of Material Harmonizing with Environment and Life. Please, for Kamita Harasensei to come forward. Okay, thank you. So you can start your presentation. Thank you, Sensei.
Thank you very much for kind introduction and good morning, audience. Selamat pagi. Good morning. Ohayou gozaimasu. So today's topic is material science, design of materials harmonizing with environment and life. I want to introduce some research of my research. So I'm very glad to be here. Then I visited the ITB 2 years ago. Then I saw the several professors. So I have a student from the ITB. So later I introduce them. So today's topic is material science, design of material harmonizing with environment and life. Then so my topic is my theme, research theme is one is highly functional biomaterials. I'm studying biomaterials, and two is the scaffolds for microorganisms. The Edwin Sensei showed he used microorganisms and also the carrier. He showed also the carrier. So that I'm interested in the carrier of microorganisms, and the three is the materials for environmental purification. When we consider my research, the materials fusion of material science and the environmental studies and life science, so we are preparing a material design based on the understanding the interaction between life and materials. Okay, sorry. Then at first, I want to introduce the research about the artificial bone. So the bone function, as you know, supports the body and protect internal organs, store calcium and phosphorus. So very important organs. So the bone is composed of the collagen and hydroxyapatite, then calcium phosphate. The main inorganic phase is hydroxyapatite, calcium phosphate materials. So artificial bone is needed when the large bone defects occurs. The treatment of large bone defects occurs. The standard treatment is autologous bone grafts. That means bone grafts are taken from the other parts of the patient's own bone is implanted into other place. So but in this case, limited amount of bone to be harvested and damage to healthy parts is a problem. And allogenic bones grafts, that means taken from other people's, give the bone grafts, then lack of donors and risk of infection. So the artificial bone artificial bone can produce mass production and no risk of infection. So the already commercialized artificial bone is commercialized and utilized in the medicine. But the problems with the present artificial bones, low ability to promote bone formation and does not harmonize well with the bone metabolism. So still now the autologous bone grafts. Now noise. Okay. Thank you. So still now even we develop we can use artificial bones still now, but still now the standard treatment is autologous bones. So the artificial bones which activate biological system, promote bone formation, and are incorporated into the metabolism are needed. So when we consider the material design, it is important to know the bone metabolism. First, the bone metabolism means the bone is replaced by new bone within several years, newly deformed by our living systems. So there's two cells, the osteoclasts, they can solve the bone, and the osteoblasts that can produce a new bone. So the replacement is occurring even the normal situation. So we need to develop the materials incorporated in the metabolism so we can regenerate the bone. We can regenerate the bone. So that we previously prepared the using the hydrothermal synthesis. We control the composition and microstructure. That means the hydroxyapatite has the calcium phosphate. Then we intended to incorporate the crystal defects. That means that we want to give the properties to be dissolved, easily dissolved properties, and also we control the microstructure. We know the crystal structure and the crystal phase. Depending on the crystal phase, the property is different. Then we successfully prepared like this porous materials. Then we inserted in the animals. So in that case, they can incorporate it in the bone metabolism and replaced by bone. That means the upper side, right side, upper side, we cannot see the white area. That means that in the downside, the porous hydroxyapatite, sintered hydroxyapatite, this is normally used artificial bone. This is remained. No problem. Remaining is not so problem, but in the rejection is not occurred but remain. On the other hand, our developed materials can be incorporated in the bone metabolism, then replaced by new bone. So bone regeneration is achieved. So control of composition and microstructure of hydroxyapatite contribute to be incorporated in metabolisms and useful materials for bone regeneration. And also to enhance the bone formation, how to improve the more properties, alpha tricalcium phosphate, another calcium phosphate, this is known as a highly biodegradable. Biodegradable means dissolved in the body. So that it is known as silicate. Silicon is a very important element for the bone formation and our skeleton formation. So the addition of silicate to promote the bone regeneration to the alpha tricalcium phosphate. Then to use the solution process, we developed the alpha calcium phosphate containing silicate. Then as a reference, silicate-free materials is also prepared. Then when we check in animal tests, so the Si5 means a silicate containing, Si0 means a silicate-free materials. Then left side is bone tissue ratio in the tissue observation. That means the bone area is high for the Si5. That means the early stage, only the 4 or 8 weeks, large amount of bone is formed. On the other hand, right side is the implant ratio. That means the remaining materials is shown. So the Si5 addition of silicates show the more remaining. I mean the control the slow absorption by the addition of silicate. So we can develop the when silicate is added to the alpha tricalcium phosphate, it becomes a bone repairing material that can promote bone formation. Early stage bone formation can achieve. So now we are developing this is a previous one is already solid, but we want to develop the more complex shape, so that we want to apply the complex shapes. So we want to develop the cement type, the injectable cement for bone repair. So we have the technology the method to prepare the granules, porous granules, so that by combining the granules with calcium phosphate as a powder, in that case we can develop the we can obtain the porous materials. And the important point is microstructure control is important. So very small micropores, and also between the granules we can obtain the macropores, large pores between among the granules gap. in that case, the cells or vessels can enter into that space. So we expect that we can obtain the high bone regeneration we can achieve. So now these materials we are conducting the animal tests. We checking whether indeed the high performance is achieved or not. Then next, I want to explain about the scaffold support material for microorganisms. Because why I'm studying this one is I think the materials which are friendly with our body is friendly even other than live matters. So that even the microorganisms maybe hydroxyapatite or biomaterials is useful for the scaffolds for microorganisms. So normally polymer and non-toxic for microorganisms and inexpensive and tough. So the polymer is usually used and also activate carbon organic absorption property. But we also use the hydroxyapatite because hydroability and biocompatibility, and hydroxyapatite shows a high adsorption property against the organic compounds. So that maybe if the hydroxyapatite is useful, then maybe it is good for the scaffold for microorganisms. So that to consider this is only basic study that we compare the 4 pellets, hydroxyapatite and carbon is coated and PVC and polyurethane. These are polymer materials, reference materials. Then when we check the attachment and the early stage adhesion of the Escherichia coli, E. coli, the very famous bacteria, and from the miscible system means many kinds of microorganisms are taken from the land. The mixed system is used. Then adhesion test was conducted. Then this is normalized by reactive activity is normalized by hydroxyapatite. Then the relationship, the reactive activity and water contact angle. We examine the water contact angle of the materials and also the activity of the adhered microorganisms were examined. So in that case, the relationship between water contact angle and adhesion was observed, and also the hydroxyapatite shows the good adhesion properties against microorganisms. Even the single system is a E. coli, and also even the mixed system. So maybe hydroxyapatite is suitable material for microorganisms adhesion. So in the previous papers, the retention force of hydrophobicity surface is higher than the hydrophobic one in adhesion microorganisms. Maybe this is consistent with the previous works. So finally, I want to introduce preparation of environmental purification materials from wastewater. So at 2 points, the one is the hydroxyapatite can remove the fluoride efficiently, and also this is a biomineral treatment. Using the biominerals, we can utilize the biominerals, so we can obtain the environmental purification materials. So oyster shell, the calcium carbonate is a calcium carbonate treated with a phosphate containing solution. Then we can produce the hydroxyapatite and calcium phosphate, maybe, or some cases amorphous calcium phosphate can produce on the surface. Then possible to prepare the hydroxyapatite can remove the F minus effectively. This is used for our practical use, maybe teeth paste, they contain the fluoride, because if the hydroxyapatite incorporate fluoride, this is stabilized. That means they can hydroxyapatite. Teeth is also hydroxyapatite. That means fluoride is stably stabilized in the hydroxy apatite. So if we treat like this, oyster shell is treated by phosphate containing solution, then hydroxyapatite is formed. Then in that case, the left side down, at first they were inserted into the 20 gram per liter fluoride concentration solution. Then after adding the materials, the oyster shell does not remove the fluoride, but after the treatment, significantly decrease the fluoride concentration. That means the removal is achieved. And also the discarded bones, this is also the biomineral. Then as I previously said, the bone is composed of hydroxyapatite and collagen. If this bone is heated suitably, we can obtain the bone char. Bone char means they contain the hydroxyapatite and also activated carbon. So the hydroxyapatite can contribute to the fluoride removal, and also the activated carbon is effective to remove the organic compounds. So I only show about the fluoride. Then in the bone, hydroxyapatite crystal is very small. So if we can treat effectively, very small size of hydroxyapatite can be obtained. That means a small hydroxyapatite means a large surface area, so reactivity is very high, so efficient. It becomes efficient fluoride removal materials. Then finally, we are doing so recently we started new material preparation. Then this was the removal of selenate ions by ion compounds synthesized using microorganisms. If we utilize the iron oxidizing bacteria, then we can prepare the iron compounds. For example, the left side, they contain the bacteria and the sulfate and the Fe2 plus, then culture. So if iron oxidizing bacteria produce or obtain the energy by oxidizing Fe2 plus, Fe3 plus, so that by using the reaction, then in the chemical reaction, the Fe2 plus becomes the Fe3 plus. Then if they contain the solution contains the sulfate and maybe the potassium or the other cations, in that case jarosite, a kind of the iron compounds can be prepared. Then if we can change the pH of the culture conditions, we can control the size or maybe the composition. Then we can obtain the jarosite, various kind of jarosite. Then this is a J1 and J4.0 is the pH difference, and J90C is chemically synthesized. Then for generally the jarosite is prepared by high temperature. For example, more than the 80 or 90 degrees Celsius. So this J90C is prepared by 90 degrees Celsius. So and S is a schwertomanite. It is well known to remove the selenate. So when we use the bacteria, even only 30 degree, very normal temperature, we can with the jarosite compared to the chemical synthesis. Chemical synthesis needs more high temperature. So the green process, we can prepare the jarosite. Then when we control the pH, we can control the size. For example, then if J2.5, we can obtain the small particle size. Then the right side is a selenate removal test. The initial concentration is 0.2 millimolar. Then the decrease means the removal. So this jarosite J2.5 was comparable to removal ability to the S2.5. So if S2.5 is better, but the schwertomanite is not stable. So the metastable phase, maybe so the biologically synthesized our prepare the jarosite may be a candidate material for removal of selenate. Selenate is very difficult to remove from the environment, so it is a very useful method. So finally, I want to introduce my laboratory members and staff. I'm specialized material science, biomaterials, and Masaki Umetsu is assistant professor in microbiology and bioelectricity. Then student, we have the 3 foreign students, then in India, and also the doctor first, the Indra Jaya Budi, also from the ITB, then he was a student for the supervisor was Professor Ali. Next presenter has was supervisor of the Indra-san. And then M1, we have the Chinese students. So we have the 3 foreign students. We are accepting the foreign students. So if you interested in my laboratory, please contact me. Thank you very much.
Thank you so much, Kamitahara Sensei, for a very interesting presentation. Please have a seat here, Sensei. So for next presenters, I will invite Dr. Ari Wibowo. So Dr. Ari Wibowo,
terima kasih.
affiliated. Thank you so much. Affiliated with Material Science Engineering Research Group, Faculty of Mechanical and Aerospace Engineering of ITB. And also he belonged to the Research Center for Nanoscience and Nanotechnology of ITB. He got his PhD from in Bioengineering and Polymer Science, the University of Tokyo, Japan. And then his research interest is on the nano and porous material for biomedical, environment, and energy application. I think this is such as the 3D printed of smart functional scaffold, of development of phantom and photocatalyst based on AOP for wastewater treatment, and also nanomedicine based on polyion complexes, and etc. I think a lot of research interest he has. And then, yeah, in terms of the publication, he wrote a lot of the international journal publications, and then, yeah, as the corresponding author and also the first author. Okay, I think time is yours for Dr. Ari, and then, yeah, after that we will have a question and answer session. Thank you so much.
Thank you very much, Professor Herto, for a nice introduction. And also, I would like to thank to the organizer, and also I would like to thank to the honorable professor from Tohoku and also from ITB. Please allow me to introduce myself. My name is Ari Wibowo. I'm from Material Science and Engineering, and also a part of the Research Center for Nanoscience and Nanotechnology. And at this time, I would like to introduce our work about visible light driven photocatalyst for removal persistent of organic material. So first of all, I would like to introduce our lab. So our lab is, we are working on 3 different topics about, we are preparing nano and porous material for biomedical, environment, and also for energy application. For the biomedical application, currently we are working on smart functional scaffold, and for the environment, we are working on femton catalyst and photocatalyst, and energy, we are working on photocatalytic water splitting for hydrogen production, and also photocatalytic carbon dioxide reduction for solar fuel. At this time, I would like to introduce our work about the photocatalyst for environment. So, as we know that last year it's very hot, and at that time Guterres, Secretary General of United Nations, said that, oh, it's not global warming anymore, it's global boiling, because the temperature is very high, and also the concentration of CO2 is very high. And also the other global issue problem is about water scarcity, as mentioned by Professor Daisuke. At this time, it affect 2.6 billion of people, about 1/3 of the population. And in here, we can use photocatalysis because we can use a solar light as the abundant energy source. And here we can see a lot of application of the photocatalyst. We can use for bioremediation, and also we can use it for medical and so on. And for the global warming, we can use photocatalyst as the to convert the CO2 to become solar fuel. And also for the problem of the water scarcity, we can use photocatalyst to degrade the dyes and also persistent organic pollutant. And right now we are interested with synthetic dyes because synthetic dyes is one of the produce a lot of synthetic dyes over the world. So the annual production is about 10.7 tons per year, and from this part, 2% was directly discharged and 10% was from discharged from the coloring process. And actually, the synthetic dyes is categorized as the persistent organic pollutant, which is persistent and also highly toxic and accumulative. So as you can see in here, this is the example of the picture accumulation of the dyes in the river. And to solve this problem, we can use photocatalyst. As you can see in here, the photocatalyst can degrade any organic pollutant to become CO2 and also water. So it become harmless using solar light as the energy, and then this is the photocatalyst. And at this time, the most important, the most mainly people use titanium oxide because titanium oxide is commercially available, low cost, high quality, and also low toxicity. However, if we want to use solar sunlight as the energy source, we need to know that actually the solar sunlight is not single wavelength. The solar light, you can see this is the spectrum of the sunlight. So actually, titanium oxide that was widely used as the photocatalyst has a wide band gap, large band gap about 3.2, which is in the UV region. It means titanium oxide can only absorb 5% of the overall the sunlight. So in this case, we need to switch from the we need to reduce the band gap and switch the energy absorption from UV to become visible light. And at this time, we would like to introduce our strategy to reduce the band gap. We can replace the titanium oxide with low band gap materials such as graphite carbon nitride, and this is already published in reaction chemistry and engineering. We can also reduce the titanium oxide to become black titania, and we can use the heterojunction to reduce the band gap, and also we can dope the titanium oxide with the nitrogen dope. And in here, I would like to introduce three of our work in here. So first, please allow me to introduce our work about graphite carbon nitride, which is published. The first author is Indra Jaya Budiarso, which is already a PhD student in Professor Kami Takahara. So this is as a collaboration between ITB with the University of Tsukuba. And in here, graphite carbon nitride is very attractive and considered as the frontier photocatalytic material because they have a lot of application, and they have a lot of advantages such as visible light active, suitable band position, and metal free and low cost. Because of that, a lot of people working on graphite carbon nitride, and as you can see in here, at 2022, the publication about the graphite carbon nitride is about 12,000. And for application of the photocatalyst graphite carbon nitride, there's two problems that reduce the photocatalytic activity. First, the graphite carbon nitride has the high density, 1.94. It means if we utilize it in the wastewater treatment, it will sink immediately, and the light cannot penetrate to the water. As you can see in here, this is the graphite carbon nitride in water. It will sink immediately. And the second problem is fast electron hole recombination. To solve this problem, we can use support, material support, floating support to elevate from here, sink, and then using this floating support, we can bring this photocatalyst to the surface. So with the access, maximum access with sunlight, and also with the maximum access with the oxygen. And to solve the problem with the fast electron hole recombination, we can use the electron acceptor donor. In this case, we use polydopamine. And this is, as you can see in here, the direct reflectant to determine the band gap. As you can see in here, the band gap is 2.8, which is in the region of the visible light, so they can absorb the energy from the visible light. And by adding the PDA, we can see the PL decrease significantly, about 21 lower. So it means the electron hole recombination is highly suppressed because the PDA could act as the electron acceptor material. And we use the floating support, and also we add the Gaussian in here. So according to the XPS result, we can see that actually in here this is the GCN, and this is after the addition of the PDA, the peak is disappear, because as you can see in here, the NH2 is disappear, because this is from here they use it for the interaction. So this is, it mean this point as the functional, this is the interaction site between the GCN with the PDA. And from this red peak in the XPS, we can see the peak in here by addition of the PDA, it increased, and also in here it also increased. So this is the interaction site between the floating support and the PDA. And based on the photocatalytic degradation under visible light irradiation, we can see that without the catalyst, no degradation. Only GCN is about 8.4%, and by adding the floating support, we can increase up to 20%. And since we use only 1/10 of the common work in here, we make a apple-to-apple comparison, and in here we are quite promising based on the degradation photocatalyst from the concentration. And this is the scavenging study. We found that actually the main contribution of the radical in here is the oxygen radical in here, because we can see the scavenging study show that the benzoquinone decreased significantly. And this is what we propose about the mechanism photocatalysis. The second one is about black titania, producing black titania. This is a collaboration between ITB with Nanoseton Indonesia, and also and US, and also port from Poland. And black titania, as you can see in here, the color, the origin titania is white, and after reduction it become gray and also become black, because the band gap is reduced in here, and we can observe in here they can absorb, this is the solar spectrum, they can absorb the energy more than the original titania. However, the current strategy to produce the black titania using hydrogen gas, or also using sodium borohydrate, but they use furnace heating, which is long processing time and high energy consumption. So fast and low energy consumption is needed. In here we use microwave heating instead of using the furnace heating, because microwave heating offer rapid heating, and also more uniform. And in here, as you can see in the XRD, we can see that this is the original, and this is by increasing the concentration of the sodium borohydrate, we can observe gradually from here we didn't observe significantly, but from the 40% and 50%, we can observe a small peak which is correlated with the Ti3O5, which is the reduction of the titania. And as you can see in the higher term, high resolution TM, we can see this is the original titanium oxide, which is, we can see the pattern in here, but after reduction, we can see the amorphous part in here in the surface, which is kind of the core cell structure based on the selected area electron diffraction. We can confirm that this is this one is correlated with the Ti3O5, which is consistent with the XRD. And also based on the XPS result, we can see that in here the titanium 3 plus peak was observed at 40% and also for 50%. So this is consistent with the XRD, and we can found the reduction in here. And based on the optical and photoluminescence, we can see that actually the band gap decreased by increasing the sodium borohydride concentration, and also the energy transfer efficiency increased from 12.9 to become 30.6. And by the photocatalytic degradation, we can see that without the catalyst, no degradation in here. And this is by increasing the concentration of the sodium borohydride, we can observe this is the black titania, and we can observe the catalytic activity increase. And also the quantum yield also increased by increasing the sodium borohydride. And this is the scavenging study, which is we also found in this case the oxygen radical is the most dominant in here. And the last part is about the preparation of the heterojunction between zinc oxide with the reduced graphene oxide and iron oxide. This work is as the collaboration between ITB with Brin and also Prasta Mulia, and also from Poland. And we use zinc dross. What is zinc dross? Zinc dross actually a waste from the industrial galvanizing process, which is about more than 650,000 tons per year. And zinc dross, the content, zinc content in here up to 60%. So it's potential as the production of the zinc dross. And normally in the zinc dross, because they use it for the galvanizing process, a trace amount of the iron exists in this material, about 3.9%. And normally if we want to use it as the precursor for zinc oxide, we need to remove it, because this is considered as the impurity. However, in our case, we didn't remove it, because we consider it not as the impurities, but as the precursor for to prepare the this composite, because we want to reduce the band gap by making the heterojunction. And not only if we use the zinc dross as the waste, industrial waste, we can get the cheap raw material, and also we can preserve our environment. So this is the material characterization result from the SCM, EDS, and also this is the DRU UVVs. We can observe that all necessary element in here, iron, carbon oxide, and also the zinc was exist in this RGO zinc dross material in here. And also this is the band gap of the zinc oxide, 3.3, and by using the precursor from the zinc dross containing the iron oxide, we can reduce the band gap to become 2.7, which is in the visible region. And also based on the time resolved photoluminescent result, we can see that the by adding the reduced graphene oxide itself is the conductive material. So by introduced reduced graphene oxide, we can prolong the recombination time from 2.2 to become 3.6 nanosecond, and we can increase the energy transfer efficiency from 9.2 to become 23.1%. And the photocatalytic activity, we can see that without the catalytic, no degradation, and also zinc oxide itself in the visible light is not active. We have the data in the UV light, they're more active than here, and by adding the RGO, we can increase the photocatalytic activity, and this is the mechanism. So this is the light, we can increase the, so the electron will excited, and then they will become oxygen and also hydroxyl radical to degrade the dyes in here. So before I close my presentation, I would like to thanks to the funding support from ITB and also from the ministry, on also the collaborator and also the student. This is the picture of my student, and this is the Indra, that a PhD student in the Kamatya Sensei lab. Thank you very much for your attention.
Thank you so much for your kind presentation, Dr. Ari. Now let's come up with the question and answer sessions. Okay, I have one from the student, I think. Yeah. Okay, please. Any souvenir? Yeah. Okay. Asking first and then souvenir next.
Thank you for the presentation. My name is Sarah. I'm from Nanoscience and Nanotechnology program. I have 2 questions. The first one, the first presenter. So I would like to ask about how is the trend nowadays regarding the synthetic bone making in utilizing the 3D printer? And the second question for Dr. Ari Wibowo, I can see that the titanium dioxide that you use as the photocatalyst material is based on the powder form. And how is the possibility to make as a device, for example, by integrating it with the substrate, and how will be the performance look like? Thank you very much.
Okay, thank you very much. At first, 3D printing is a very interesting topic. Then I'm not studying, but some researcher already preparing the artificial bone. And also some cases they try to include the cells also by 3D printing. So maybe in the future, or some cases already practically used by the 3D printer. Then maybe in the future it becomes the main production. Maybe not now, but maybe now studying is conducting, so maybe it's one of the useful method, I think. Thank you very much. Okay.
Okay, thank you very much for the question. So we can, because the titanium oxide is a particle, so we can use a Dr. Blade process to make a film in the substrate, and also we can, in our case, we use the anchor molecule to make sure that the titanium oxide or other photocatalyst material is attached chemically to the surface, to the substrate. In our case, we use a floating. So to ensure the photocatalyst can have maximum access to the light and to the oxygen. So you can use Dr. Blade as a slurry, make a slurry, and then Dr. Blade printing just to make to attach to the surface. Or if you want to make sure that the photocatalyst is embedded or attached permanently to the support material, we can use the anchor material. Okay.
Is enough? It's clear for you? Okay, thank you so much. Because of the time limitation, I would like to have one last question from the another students, maybe. Okay, please. Yeah. And souvenir has been given to him, to her.
Test. Thanks for the opportunity. My name is Muhammad Salahuddin. Currently, I'm a master student of Industrial Engineering and Management. I have question to Mr. Ari Wibowo. I interested in photocatalyst material. Yes. So in my topic for my thesis, I have researched to solve the problem of the waste that in manufacture industrial products like toxic and hazardous waste. Maybe in Indonesia we usually call limbah B3, limbah bahan berbahaya beracun. From as you mentioned before, the role of the material, it can be used for antibacterial or sterilization, and so it can be decreased in pollutant in air or water. So my question is it possible to use photocatalyst technology or material to solve the problem of the toxic and hazardous waste that manufacture industry usually produce to decrease the negative impact to environment? Maybe that's it. Thanks for the opportunity.
Okay, thank you, Mr. Salahuddin, for the question. So I saw several researchers from I think I didn't remember from the NTUST from Taiwan. They use the photocatalyst or advanced oxidation process to reduce the chromium ion. Chromium ion is the toxic waste from the industry to reduce to make it more less harmful compared to the chromium 6 plus. So this is possible to use the advanced oxidation process or also photocatalyst to treat the toxic waste from the industry. And also because they generate the reactive oxygen species, this is very powerful to degrade the membrane of the bacteria. So that's why we can use it as the antibacterial material.
Thanks for the answer.
Okay, thank you so much. I think because of the time limitation, and so happy to have your questions. So this is the end of our session. Thank you so much for coming to Akari Sensei and also Ari Sensei for the nice presentation. Also for all of you who has joined us this morning. So we'll meet again after the lunch break, and then we still have 4 speakers after the lunch break. Thank you so much for participation. Selamat siang. So good afternoon.
Okay, thank you so much to our moderators, Professor Arishyadi, and thank you so much for the speakers. Thank you. Okay, so we will have a feast now. We have for about 1 hour. I think it has problems with the speakers over there. We have for about 1 hour to enjoy our lunch. We have Indonesian cuisines, Indonesian traditional cuisines, and also meatballs. Okay, so enjoy your lunch. Please be back here at 1:30. Thank you. Enjoy your lunch.